The point of this problem is to make sure that you understand the difference between the domain and the range of a function. In this particular problem, we're given the name of the function, f of x. And when you see a graph that has both y and x on it, typically speaking, we think of y as being a function of x, y equals f of x. When you talk about the domain of a function, the domain is the set of inputs that give outputs, which doesn't make too much sense unless we relate it to the graph here. Usually we think of the inputs as the x's that correspond to y's. So we're looking for x's on the graph. When you talk about the range of a function, these are the outputs from the inputs. So all of the values of y came from a value of x. So the range will consist of all of the y values on the graph. Once we have that idea down, we can start looking at the three parts of this problem. The first part, A, is to find the domain of the function f. So with my definition, these are the inputs that give outputs, or all of the x's that give a y. So if I look on the x-axis, starting over here at about -5, going up to about x equals 0, all of those x's correspond to a y value on the graph, so that's going to be my domain. The domain of f is going to start on the left at -5, it's going to go to 0, and I have to be really careful to make sure I either include or exclude those endpoints. When x is -5, over here, if I look up at the graph, there's an open circle on the line there, and that tells me that that point is not included. So there's no y value, and I must exclude -5 from the domain. I'll do that with a parentheses. When I look at x equals 0 over here, down at the bottom, there's a solid circle that tells me there is a point corresponding to x equals 0. Looks like y is equal to 3 there. Because there is a corresponding y value, I include 0 in the domain, and I show that with a square parentheses. The conversation is basically the same for finding the range of a function. The range are all of the y values that come from x's, or it's all the y's on the graph. So if I start down here at y equals -3, climb up the y-axis, it looks like I have y values from -3 up to 3. And again, I have to be careful to make sure I either include or exclude those endpoints appropriately. So the first one, y is equal to -3. That is down here. There's a solid circle. Because there's a solid circle, I include the point, and I include -3 in the range. When y is equal to +3 up here, there's an open circle. Because of the open circle, there is no x value, and I must exclude that y value from the range. I'll show that with a parentheses. Part B. I'm asked to find f of -3, figure out what that's equal to. And again, I want to remember that we like to think about y being equal to f of x. So really what we're being asked to find here is what is the y value. Y is equal to when my input is -3, my input is my x value. So I'm going to go to the graph, I'm going to go over to x equals -3, that's right here, and I need to find the corresponding y value. The corresponding y value looks like it's -1. So what we could say then is f of -3 is equal to -1. The last part, part C, is to figure out when f of x is equal to 0. And same conversation as before. F of x in its entirety is just like a y value. So if we're asked to find when f of x is equal to 0, we're really saying when is y equal to 0. So y is equal to 0 is right here, and that corresponds to this point on the graph. That point on the graph looks to me like it's at -3.5, give or take. It's kind of hard to tell, so we'll say this is approximately -3.5.